Hi, my name is Azima Bora. I've been a part of Forge Ecomaniacs for about 3 years, and today my presentation is on astrophysics. For my introduction, I'm going to be talking about 5 topics: an overview of what astrophysics is, the application, the evolution, significance, how it's used, climate change, and how it affects um, astrophysics, data analysis, and physical laws, black holes, gravity waves, and interventions. What is astrophysics? So astrophysics studies slash field involves physics, chemistry, and mathematics to understand space. Astrophysicists study the formation of stars, planets, and galaxies. They try to understand, why is the celestial realm this way? Why is the galaxy that way? They spend a lot of time researching and analyzing space. Why is a planet structured this way, and how is it structured this way? Application. So astrophysics is a field that uses a lot of science to understand the evolution and answering questions regarding the origin of the universe. Many astrophysicists try to understand the field using space missions, compositions, and the universe's evolution. Evolution. So where did astrophysics come from? So it originates back to the 17th century by Angiolo Sicci. Angiolo Sicci was considered the father of astrophysics. Angiolo was a mathematician and physicist who had a passion for astronomical studies. While there are many other astrophysicists who contribute to the findings, he was considered the founder. Significance. So this guy right here is Isaac Newton. With physical laws, we can understand the universe's significance, structure, and evolution. The significance of physical laws is that the same laws that Isaac Newton talked about are also the basic laws studied in astrophysics. Data analysis. So data analysis is used in much every single field that you come across. It's used in retail, finance, and astrophysics. Data analysis is important to astrophysics because it helps astronomers identify patterns, predict, and gain a better understanding of the universe. Most astrophysics collect data by satellite, space probes, and they use this to identify patterns and create predictions and expanding their understanding of the universe. Climate change. Astrophysics and scientists use scientific info from natural sources and equipment to study the changes of the climate change. They have satellite data, NASA observatory, and scientific info. There is a specific astrophysicist who studies this. Astrophysicist Professor Viviana Cueva uses data to improve climate models and learn more about the ocean carbon cycle. The ocean carbon cycle is the movement of water from one place to another. They exchange gases with the atmosphere while releasing other gases. Black holes. So this thing right here is a black hole. So what are black holes? Black holes are the production of massive stars' death. And these stars aren't just big. They're 8 to 10 times the mass of our sun. When these stars die, they leave such an impact on the world that it creates a dense object, also known as a black hole. What does gravity have to do with a black hole, though? This is light going into a black hole. And this is important because a black hole is pure gravitational force, meaning that there's areas in space where gravity is so strong that not even light can escape it. Characteristics of a black hole. Black holes don't emit or reflect light, so they're invisible to a telescope. However, they can be detected and studied by observing how they affect their surroundings. Black holes themselves don't have any color, but the reason why you see color around this black hole is because of the superheated gas. The superheated gas that falls into change the color as they get close to the black hole. Black holes can be surrounded by rings of gas and dust. These disks can emit light across many wavelengths, including X-rays. Gravity wave. This is a gravity wave. Gravitational wave is an invisible yet incredibly fast ripple in space. Gravitational waves travel at the speed of 186,000 miles per second. These waves can squeeze and stretch anything in their path as they pass by. More than 100 years ago, there was a great scientist, Albert Einstein, as you may have heard of him, came up with the idea of gravity in space. He predicted that something special would happen when two bodies, planets and stars, orbit each other, creating a gravitational wave, like this. But how do we know that a gravitational wave exists? In 2015, scientists detected gravitational wave for the very first time. They used a very sensitive instrument called LIGO, also known as Laser Interferometer Gravitational Wave Observatory. This device detected the first gravitational wave that happened when two black holes crashed into one another. When these two black holes crashed into one another, it created a gravitational wave. And this collision happened about 1.3 billion years ago, but it was only founded on Earth since 2015. In 2015, the ripples made it to Earth in 2015, but about 1.3 billion years ago, it happened. Isn't that crazy? Interventions. So this right here is an MRI. An MRI is used to detect like internal body organs. And it's important to astrophysics because astrophysics and magnetic resonance imaging, MRIs, are both fields that require high producing resolution imaging, often using X-rays, which can't be focused with a regular NMR. The algorithm used to create MRIs, imaging of the body's internal organs, is based on the processing NASA has developed to improve pictures of the moon surface. NASA has been working on digital image processing since the 1960s to evaluate imaging taken by satellites and probes. 2-mass redshift survey. So the 2-mass redshift survey is a project that maps the distribution of dark matter and galaxies in our local universe. This structure is the tracer of dark matter and its way of understanding how the universe has evolved. They're designed to uncover the three-dimensional structure in the galaxy's distribution. Many astronomers use redshift to measure how the universe is expanding and determine the distance to our universe's oldest objects. In conclusion, I talked about 5 topics. An overview of what astrophysics is, the significance of what astrophysics is applying, black holes, gravitational waves, and interventions. Here are my works cited. Thank you for listening.